Good morning, everybody, once again. Let's get started. Today we're going to talk about parallel and perpendicular lines. And I've got an illustration right here where I have some lines that look like they're parallel, other lines look like they're perpendicular. Remember, parallel lines are lines that would never intersect, that are coplanar. And perpendicular lines are lines that do intersect, and they intersect at a right angle. And so as I look at this line GC right here, GC surely it looks pretty parallel to line HD. And then as I look at AF looks pretty parallel to BE. And at the same time, most of them kind of look like they're perpendicular to a lot of the ones that they intersect. And so what I want to do is I want to kind of take a look and go, well, do they or are they for real parallel or are they perpendicular? And how we know that for sure is we can take a look at their slopes. And so we're going to do a little bit of Algebra 1 review today. If you don't remember, the word slope is rise over run. Slope is how we describe how steep a line is either going up or going down as it's graphed on this Cartesian coordinate plane right here. So slope is always rise over run. And rise is the change in the y value. And run, of course, then is the change in the x value. At this time, if you don't yet have something with which to write and something on which to write, make sure you get those things out because I'm going to have you jot a few things down. First of all, everyone should know that slope is rise over run. That is something that should be burned into your brain. Hopefully, you remember that from Algebra 1. But what we're going to do is we're going to take a look at that and how that applies to this situation. We've been dealing with parallel lines and when parallel lines are cut by a transversal and the alternate interior angles and the same side interior and alternate exterior and the corresponding, all these different kind of angles. But now we're going to take a look at these lines on the coordinate plane. And so we've got to figure some things out. First of all, slope. Slope is rise over run, okay, which we said rise is the change in the y value or the vertical change, and run is the change in the x or the horizontal change. And we go, well, how is that affected when we're talking about parallel and perpendicular? Well, it's pretty easy. Two parallel lines will have the same slope, and that's worth writing down. Parallel always means same slope when we're talking about lines that are graphed, okay? So when we hear parallel, we just automatically think same slope. But then when we think perpendicular is going to be different. Now, perpendicular obviously can't be the same slope because that would be parallel. And so perpendicular is always going to be opposite reciprocal slope. Okay, opposite reciprocal slope. And you might not understand what that means. Well, obviously, same slope, that's pretty easy. If the slope of one of them is 2 and the slope of the other one is 2, well, then they're parallel. They have the same slope. But perpendicular talks about opposite reciprocal. Well, if we said that the slope of one of them was 3/4 and the slope of the other one was -4/3, those two lines would be perpendicular because these are opposite reciprocals. 3/4 is opposite sign as -4/3. That's the opposite part. And reciprocal just means to flip the whole thing over. So here we have 3/4, the other one is 4/3. So these are opposite, one's positive, one's negative, reciprocals, 3/4, 4/3. So as we're talking about these lines, we want to remember slope. Slope is rise over run. We want to remember that parallel is same slope and perpendicular is opposite reciprocal. Okay, now what we're going to do is we're going to try to apply all of that to what we have going on right here. And we're going to try to figure out the slopes of these lines in this picture and see if we can determine whether they're parallel or some of them are perpendicular. And so we're going to walk right through that. Ready? So you don't have to write this stuff down right now, but I'm going to have you do a problem just like this in a second. And so if it'd help you to write this one down, then go for it. But so what I'm going to do is first I'm going to find the slope of line AF. Okay, and so to do that, I got to know where in the world A is. And so I look, and A is at -3, 5. That's where this point is right here, -3, 5. And F, so that's A, and so then F is at where? F is at 0, didn't go anywhere on the x-axis, and then down 5, so -5. Okay, so A is at -3, 5, F is at 0, -5. Now, a lot of times slope is abbreviated with a lowercase m. And remember, slope is rise over run, or change in y over change in x. And so to find that, we subtract the two y values, and we subtract the two x values. Now here's the thing. It doesn't matter which y goes first or which x goes first. What does matter, don't miss this, what does matter is that these 2 points are going to be above and below, or these 2 coordinates are going to be above and below each other, and these 2 coordinates will be above and below each other. Doesn't matter which one goes first. So I could say 5 minus a negative 5. Now notice I started with the orange one there. Okay, this 5 came from right here, 5. And so if that one came first on the top, then on the bottom, the negative 3 has to come first, minus the 0. And you can see how that works. So now I go, these 2 both came from this point, and these 2 both came from this point. Okay? Now I could have swapped the order entirely. I could have said, well, we're going to just mix this around. I could have said negative 5 minus 5 all over 0 minus 3. Or 0, I'm sorry, minus a negative 3. I could have done that as well. As long as these 2 come from the same point and these 2 come from the same point. Doesn't matter what order. So that's important. All right, so let's go ahead and do the math here and go, okay, so if I have negative 5 minus 5 more, that would put me all the way back to negative 10. And 0 minus a negative 3 is like 0 plus 3, so that would be 3. So I've got negative 10 over positive 3, which is the same thing as negative 10 thirds. Okay? So we know the slope of AF is negative 10 thirds. All right, let's go ahead and find the slope of BE. Well, we know that B is at 0, 5, and we know that E is at 3, negative 4. And so, to find the slope, it's always going to be the change in y, so it's always going to be y minus y over x minus x. And so my y minus y, I can say 5 minus a negative 4 over 0 minus 3. 5 minus negative 4 is like 5 plus 4, so I get 9. 0 minus 3 would be negative 3. So this ends up being negative 9 thirds, which simplifies to negative 3 over 1, or negative 3. And so my job to do right now is to say, okay, so are these 2 lines parallel? Is AF parallel to BE? Well, to be parallel, they'd have to have the same slopes. The slope of this one is negative 10 thirds, and the slope of this one is negative 9 thirds. And while that's really close, it's not the same. So those 2 lines are not parallel. All right? So it's worth noting what the slopes of these lines are, but it's also worth noticing that these are not parallel. We're going to try to find the slopes of the other lines, so I'm going to hold on to these. Okay, so we'll say, well, we know the slope of BE is negative 3 over 1. Okay, so we'll just kind of keep that up here for reference. All right, now let's look at the slope of the other 2. So I'm going to find the slope of GC. So G is at negative 5, 1, and C is at 4, 4. Okay, we'll find the slope of that. Slope is always the difference of the y's over the difference of the x's. Remember, y's always go up top, and it's the difference, so it's always subtraction. So I'm going to say 4 minus 1 over 4 minus a negative 5. So 4 minus 1 is 3. 4 minus a negative 5 is like 4 plus 5, so it's 9. So that would reduce to 1/3. All right, so the slope of GC is 1/3. All right, and now let's go ahead and find the slope of the last one. And so the slope of the last one is going to be BE. No, I'm sorry, no, we already done BE. We're looking for a slope of HD. So H is at negative 5, negative 4. And D is at 5, negative 1. And so the slope is going to be, it's always going to be the difference of the y. So I could say negative 1 minus a negative 4. If I started with negative 1, then on the bottom I got to start with 5 minus a negative 5. So negative 1 minus a negative 4 is like negative 1 plus 4. So that would be a positive 3. 5 minus a negative 5 is like 5 plus 5. So that'd be a positive 10. So I have 3 tenths. All right. So now here's the important thing. Let's take a look at this. So the slope of HD is 3 tenths. All right. We've got all of that. Now, let's kind of zoom in and see what we have going on here. Well, we know that the slope of AF is negative 3/10. And then if we look down, the slope of HD is positive. The slope of AF is negative 10/3. And the slope of HD is positive 3/10. Those two are opposite reciprocals. So as we look at the picture, AF, which is right here, must be perpendicular to HD, which is right here, because the slopes are opposite reciprocals. Also, look at the slope of BE. The slope of BE is negative 3/1, while the slope of GC is positive 1/3. Again, opposite reciprocals. So that would mean that the slope of GC is perpendicular to the slope of BE. So while we didn't have any parallel lines, we do have two pairs of perpendicular lines. All right, before we go on, there's one more thing that we'll see defined differently in your book, and some books define it this way, is they say perpendicular slopes, not only are they opposite reciprocals, but they say if you take two perpendicular slopes and multiply them together, the result will always be -1. So if we take negative 10/3 and multiply that by positive 3/10, and when you multiply fractions, you multiply straight across, so 10 times 3 is 30, and 3 times 10 is 30, and then the negative sign just carries, and 30 over 30 would be 1, so this would be -1. So the product of two perpendicular slopes will always be -1. That's another way you can tell they're perpendicular. Personally, I think it's easier to look for opposite reciprocals, but that's another option that you could do. You can always multiply them, and therefore you know that if their product is -1, then you have some perpendicular lines. All right, you've seen me do it. It's your turn now. Ready? Here you go. I've got 3 lines drawn in here. I have the points given to you on your paper right now. What I'd like you to do is find out if EF is parallel to AB or parallel to CD, or if any of these lines are parallel. So I need you to find the slopes. I'm going to have you pause the video right here. You guys find the slopes, and we'll talk about it. Okay, hopefully at this point you have figured out whether these are parallel, or not. And so we're going to take a look at that, all right? So I'm going to start with AB and go, okay, AB. We're going to talk about the slope of AB. And a lot of times, like I said, slope is lowercase m. And so if I'm looking at A and B, I'm going to start with the coordinates of B, and I'm going to say 5 minus, that's the y value, minus a -5. Those are the difference to y values. And I'll say, if I started with the 5 over here, I got to start with the 3 for the x value on the bottom, minus this -2. Okay, so 5 minus a -5 is 10. It's like 5 plus 5. And 3 minus -2 is like 3 plus 2, so it's 5. So 10 over 5 is 2. Okay, that reduces to 2. Let's find the slope of CD. Slope of CD, well, we got to do the y value, so I'm going to do 2 minus a -5 over, if I started with 2, then I got to start with 5. 5 minus 2. 2 minus a -5 is like 2 plus 5, so that's going to be 7. And 5 minus 2 is 3. So 7/3, which is actually the same thing as 2 and 1/3. So that's really close to 2, but that isn't 2. So AB is not parallel to CD. Well, let's take a look at EF. Well, EF. The slope of EF, we got to do the y's minus the y, so I'm going to say 5 minus a -3. And if I started with the 5, then I got to start with the -2. -2 minus -5. All right, so 5 minus -3 is like 5 plus 3, so that's going to be 8. And then -2 minus a -5. That might sound crazy, but it's like -2 plus 5, so that would be +3, which is 2 2/3. And so now we can see that AB has a slope of 2, CD has a slope of 7/3 or 2 1/3, and EF has a slope of 8/3 or 2 2/3. And so none of these lines are parallel because none of them have the same slope. Remember, parallel is always about same slope. Okay, we're going to move on. Next, we're going to do some basic Algebra 1 review right now. We're going to talk about slope-intercept form. Hopefully you remember something about slope-intercept form. Slope-intercept form is y equals mx plus b. And when people say, well, why do they call it slope-intercept form? Well, we call it slope-intercept form because that is the slope, m. And this is the y-intercept, b. So like right here in this graph drawn over here, this right here, where the line crosses the y-axis, that would be the y-intercept. And how much this rises versus how much this runs, that's going to be the slope. And so that's right here. And so these are really easy to graph. We love having equations in y equals mx plus b because everything is given to us. If we have y equals 4x minus 17, we know the slope is 4, and we know the y-intercept is negative 17. It's that easy. And we can identify slope-intercept form because it's always going to say y equals. If we have an equation that says, 2x plus 8y is equal to 16, we don't know what the slope is because it's not in slope-intercept form. Now, we could put it in slope-intercept form just by doing what I just said. We have to make it say y equals. So if you solve this equation for y, get y all by itself, then you'll have it in slope-intercept form, and you'll know what the slope is and what the intercept is. So let's think about how I do that. First thing I'd do is I'd subtract 2x from both sides. That would leave only 8y on this side, and on this other side, I'd have negative 2x plus 16. Then I'd have to divide everything by that 8, trying to get the y all by itself. And that would mean I'd have y equals, now negative 2 over 8 is the same thing as negative 1/4, x plus 16 divided by 8 is 2. This is in slope-intercept form. And so therefore, that right there is the slope. The slope is always the number in front of the x when it says y equals. And this right here is the y-intercept. The y-intercept is always the number that doesn't have an x with it when you're in the form y equals. So I would know that the slope of this line is negative 1/4 and the y-intercept is 2. All right, this is something you should be able to do. So right here, we could graph a line. I've got this in the form y equals mx plus b. That's my slope-intercept form. So if that's the case, then we know that this right here is the slope and this right here is the y-intercept. Okay, and so I could graph this pretty easily. I know that the slope is 1/2, the y-intercept is negative 2. So I could go down to negative 2, and we'll say 1, 2, right about there. All right, and the slope is 1/2, which means I go up 1 and over 2. Up 1 and over 2. Up 1 and over 2. Up 1 and over 2, and so on. Okay, and so there would be my line. It would look something like that. All right, so the graph of this equation would look like that. Now I want you to try. Draw a basic and simple graph just like I did right here. Doesn't have to be anything complicated, but real quickly, I'd like you to try to draw a graph and graph this equation. We're going to take a break for just a second. We can pause the video right here. I want you guys to take about 2 or 3 minutes, draw a basic graph, and try to graph that line. All right, we'll touch base in just a second. Okay, hopefully that was enough time for you to figure this out. And so I look at this and go, man, this is in the form y equals mx plus b. This is the slope. This is the y-intercept. So it's got a y-intercept of 6. 1, 2, 3, 4, 5, 6. It crosses the y-axis at that point. It has a slope of negative 2/3, which means I go down 2 every time I go over 3. And I go down 2 every time I go over 3. Down 2 over 3. And it's that simple. So this right here would be the graph of this equation. Okay? Y equals negative 2/3, that's the slope. X plus 6, that's the y-intercept. Okay? Simple enough. Hopefully this is what you got, or you have something relatively close to it. All right, next. What I want to do is I want you to now, since we've talked about slope-intercept form, I want you to look and I want you to come up with 2 equations, both in slope-intercept form. I want you to come up with an equation that has a slope of 4 and a y-intercept of negative 17. And then also, I want you to convert this equation, 2x plus 3y equals 18, into slope-intercept form. Now, these are 2 different problems that have nothing to do with each other. The only thing in common is that both of them need to end up being in slope-intercept form. Okay, so the first one is you're going to write an equation in slope-intercept form of a line that has a slope of 4 and a y-intercept of negative 17. And the second one is you're going to convert this equation, 2x plus 3y equals 18, into slope-intercept form. So we'll pause the video right here for just a couple minutes so you guys can write these two equations. All right, and we're back. And so hopefully you were able to figure this out. This first one is so easy. Slope-intercept form is y equals mx plus b. So we just plug this in right here, and we plug that in right there. And so we would get y equals 4x minus 17. Hopefully this is what you have. That's the equation of a line with a slope of 4 and a y-intercept of negative 17. Okay, for the second one, it's going to be at least a little bit more challenging. We can put this in slope-intercept form if we get the y all by itself. So we have to solve this for y. So I start with the equation 2x plus 3y equals 18. And I'm going to subtract 2x from both sides. When I do that, I get 3y is equal to negative 2x plus 18. And then I just divide by 3. But I have to divide everything by 3. So when I do that, I get y equals, because these 3's cancel out, negative 2/3 x, negative 2 over 3 is negative 2/3, plus 18 divided by 3 is 6. So this is the same equation as this, it's just written in slope-intercept form. And so see, in this form up here, I couldn't tell what the slope was or what the y-intercept was. But down here, it's really easy. The slope is negative 2/3, and the y-intercept is 6. Pretty simple. All right, now let's try something a little bit kind of the same, and we're going to apply everything, put it all together right now. Okay, so here's what we're looking at. I have given, or been given rather, two equations, and I want to know, are these equations of lines that are parallel, perpendicular, or neither? And so I can't tell unless they're in slope-intercept form. Unless they say y equals, I can't tell what the slope is. And that's the only way I'm going to figure out whether they're parallel, perpendicular, or neither. I got to know the slope. The y-intercept, I don't care about, but I have to know the slope. And so for this one, let's solve this first one. I'll subtract 2x from both sides, and that'll leave me with 4y is equal to negative 2x plus 20, and then divide everything by 4. Divide this by 4, and this by 4, and this, and I get y equals, now negative 2 over 4 would be negative 1/2 x plus 20 divided by 4 is 5. So the slope of this first one is negative 1/2. On the second one, do the same thing. Subtract 3x from both sides, and I would get negative 6y is equal to negative 3x plus 18, and divide everything by negative 6. When I do that, the negatives and the 6's cancel out, the negatives cancel out, so I get y is equal to 3 over 6 is 1/2 x, and 18 divided by negative 6 would be negative 3. So the slope of this one is positive 1/2. So the slope of the first one was negative 1/2. Slope of the second one is positive 1/2. So are these parallel, perpendicular, or neither? The answer is they're neither. They're not the same slope, which is what I need for parallel, and they're not opposite reciprocals, which is what I need for perpendicular. They're opposite, but they're not reciprocals. So these are just plain old lines. They're neither. Okay, let's look at the second set, see if we can figure that out as well. All right, we should be able to move a little bit quicker on this one. Subtract 2x from both sides. That's going to leave me with 4y is equal to negative 2x plus 10. Divide everything by 4, and we get y is equal to negative 2 over 4x plus 10/4. So that's the same thing as y equals negative 1/2 x plus 5/2 or 2.5. The second one, I'm going to, let's see, try to get y all by itself. So I'll bump the 1 over to the other side. And so I can, or let's first start by maybe just flip-flopping the whole equation, saying 1/2 y plus 1 equals x. All I did was flip everything around. I can bump that 1 over the other side by subtracting 1. That'll give me 1/2 y is equal to x minus 1. And the only way I can think of to get rid of that 1/2 would be to multiply everything by 2. So I'm going to multiply everything on this side by 2 and multiply everything on this side by 2. Make sure you distribute on that right side. So the 2 and the 1/2 cancel each other out. I'm left with y equals 2x minus 2. Okay, so the slope of this one right here is negative 1/2. Slope of this one is 2. those are opposite reciprocals because 2 is the same thing as 2 over 1, which is the reciprocal of 1/2, and one of them is positive and one of them is negative, so they are opposite reciprocals. So these two lines right here are perpendicular. All right, that's important. All right, well, now it's your turn. What I'd like you to do is I'd like you to look at these two sets of lines, and I want you to determine whether these are parallel or perpendicular. Wait, I've given you the exact same lines. You can't do that. Hang on one second. We got to make a couple changes real quick. All right. So I still want you to try the exact same thing, but I got to give you some new lines because I accidentally wrote the same ones. So what you're going to do is you're going to do this. I'm going to say, what if we had 6x plus 3y equals 12? And on this other part, we'll have 10x minus 2y equals 6. Okay, I want to know, are those parallel, perpendicular, or neither? And then for the second set, we'll go ahead and say, well, we'll say this first one is x is equal to 1/4 y plus 1. And the other one is, how about 8x minus 2y equals, not 8, equals 10. Okay, go ahead and solve these, put them in slope-intercept form so you can look at the slopes and figure out whether they are parallel, perpendicular, or neither. And we'll talk about them in just a second, so we can pause the video right here and we'll get it started again in a few minutes. Okay, so let's see what you got. All right, for these, I'm looking at, are they parallel, are they perpendicular, or are they neither? This first set, I got to get y all by itself. So I'm going to subtract 6x from both sides, and I'm left with 3y is equal to negative 6x plus 12, and divide everything by 3, and I get y is equal to, now negative 6 divided by 3 would be negative 2x plus 4. I don't really care about the y-intercept because I'm only focusing on the slope to figure out parallel, perpendicular, neither. So the slope of this one is negative 2. I look at this next one. I go, okay, I got to subtract 10x from both sides. I get negative 2y is equal to negative 10x plus 6. So now I divide everything by negative 2. And when I do that, I get y is equal to, negatives cancel out, 5x minus 3. Slope of this one is 5. So I have a slope of negative 2 and a slope of 5. Well, they're not the same, so they can't be parallel. They're not reciprocals. They are opposite, but they're not reciprocals, so it can't be perpendicular. So it's neither. Those are just lines. Okay, let's look at this next step. We got to make it say y equals. We notice this first one says x equals, but that's not what we want. We need it to say y equals. So I'm going to spin the whole thing around, make it say 1/4 y plus 1 equals x. Go ahead and subtract 1 from both sides. That'll get us to 1/4 y equals x minus 1. And now I can get rid of that 1/4 by just multiplying everything by 4. These cancel out, and I can get y equals 4x minus 4. Let's look at the next one. Over here, again, I got to get that y all by itself. So I subtract 8x from both sides. That gives me negative 2y is equal to negative 8x plus 10. Divide everything by negative 2. Negatives cancel out, 2's cancel out. I get y is equal to, the negatives cancel out, 8 over 2 is 4x, and 10 divided by negative 2 would be negative 5. So the slope of this first one is 4. The slope of the second one is 4. So what do I know about these? These have got to be parallel. Why? Because they have the same slope. Doesn't matter about that y-intercept. It just matters about the slope when I'm talking about parallel, perpendicular, and either. Fantastic. Hopefully that's what you got. All right. Now, last thing we're going to look at today is what if I give you the equation of a line and then some other point? Okay. What I want you to do, now this point right here, this point 6,5, this isn't on this line. It's just floating off in space somewhere else. What I want you to do is I want you to come up with the equation of a line that is parallel to this one, but passes through this point. And then I want you to come up with another equation of a line that's perpendicular to this one, but passes through this point. Now, you might not remember anyway how to do this, but you'll see it's so easy. First of all, it's easy because this is written in slope-intercept form. So everybody can see the slope of this one is 3. So that means parallel, same slope, I want the slope of 3. Perpendicular, opposite reciprocal, I'd want a slope of negative 1/3. So that's a good start. So from there, what I'll do is I'll take my slope-intercept form, y equals mx plus b, and plug in the only thing I know. So I can rewrite it, y equals 3x plus b. Now, that's not a good enough equation because I got to know what b is. And I don't have b, but I do have an x and a y right here. And so I can take those two values and plug them in. And y is 5, so I can make it say 5 equals 3 times my x is what, 6 plus b. So that would be 5 is equal to 18 plus b. So if I subtract 18 from both sides, I get that b is equal to negative 13. Now I can take this and plug it back in right there and rewrite my equation. And so at this point, I know the equation would be y equals 3x minus 13. This is the equation of a line that's parallel to this original line, but passes through this point over here. Okay, now we're going to try the exact same thing, but for perpendicular. Okay, so perpendicular, we know the slope we want has got to be this negative 1/3. So we can plug that in. We start with y equals mx plus b, and we plug in the negative 1/3. So we get y equals negative 1/3 x plus b. Okay, now to figure out what b is, we got to go back and plug in our x and y values. So that would be to say it's going to be 5 equals negative 1/3 times 6 plus b. So that would be 5 equals negative 1/3 times 6 would be negative 6/3 plus b. Negative 6/3 is the same thing as negative 2. So then add 2 to both sides, and you'd have 7 is what b must be. And I can take that and plug it back in for my b value. So then my equation would be y equals negative 1/3 x plus 7. And this is the equation of a line that is perpendicular to this line and passes through this point. All right? We have y equals 3x minus 13 is parallel, and y equals negative 1/3 x plus 7 is perpendicular. All right. Now that we've done that, it's your turn. I want you to find the equation of a line that is parallel to this line but passes through this point. And I want you to find the equation of a line that's perpendicular to this line that passes through this point. So you're going to take just a couple minutes to do that right now. We can pause the video, and then I'll come back and make sure you got it right. Okay, and we're back. So let's take a look at this. All right, very first thing I hope you notice is we've got to make this say y equals because we need to know what the slope is. So I'm going to subtract 2x from both sides, and that would give me negative 4y is equal to negative 2x plus 12. Divide everything by negative 4. The negatives cancel out and the 4's cancel out. I'm left with y equals, the negatives cancel out. 2 over 4 is the same thing as 1/2. And then 12 divided by a negative 4 is negative 3. So I got y equals 1/2 x minus 3. So what's the slope? Right here, 1/2. So if I want parallel is same slope. So I want that slope. So I'll say, well, I know I want y equals mx plus b. Plug in the slope you have, y equals 1/2 x plus b. Then plug in the point. This is your x and this is your y. It's always alphabetical order, x, y. So that would mean it's 3 is equal to 1/2 times 4 plus b, which is to say 3 is equal to half of 4 is 2 plus b. If you subtract 2 from both sides, you get that b is 1. So the equation of the line that's parallel to this original one, but passes through this point is, once I plug this, there we go. Once I plug this in for right here, I would get y equals 1/2 x plus 1. This line is parallel to this first line and passes through this point. Now let's try perpendicular. Hopefully that's what you had, okay, for this one. So now let's try perpendicular and see what we can get. Let me get rid of some of this. Okay. Now we said parallel slope was 1/2. So a perpendicular slope would be the opposite reciprocal. So it's got to be negative since that one was positive, and we flip it, which would be 2/1, or the same thing as -2. So I start with the equation y equals mx plus b. I plug in the -2 for the slope. I get y equals -2x plus b, and then I plug in my points, x, y. Say 3 is equal to -2 times 4 plus b. So 3 is equal to -2 times 4 is going to be -8 plus b. If I add 8 to both sides, I get 11 is equal to b. So therefore, my equation is y equals -2x plus 11. That came from right here. This went right there. Okay? And so this is the equation of a line that's perpendicular to this line, but passes through this point. Hopefully that's what you had. All right. So now, in review, let's make sure we understand this. Slope. What is slope? Slope is rise over run. And how do we find that? Well, we subtract the y's over us subtracting the x's. And what does parallel mean? Parallel means same slope. And perpendicular was a little bit different. Perpendicular was opposite reciprocal. Remember, opposite means the opposite sign. One's positive, the other one's negative. Reciprocal means you flip the whole thing, but it's opposite reciprocal slope. And lastly, slope-intercept form is always y equals mx plus b, and you can tell if something's in slope-intercept form because it will say y equals. All right. Hopefully that was enough to get you a good reminder of some Algebra 1. We're getting ready to work on the homework right now, and so good luck. I'll see you soon.